Hey guys, how we doing? We are back in Chapter 8, Section 4. Mostly this is just kind of like organizing
Yes,
the shapes that we've talked about and
basically.
are going to talk about. And
More
just,
refining.
yeah, kind of put them in categories and just kind of giving them some ways of remembering what shape is what category and things like that.
The
So,
family tree of
yeah.
parallel.
Yeah, I love that diagram.
quadrilaterals.
It puts it all
Yeah.
in one place.
Yeah.
Yeah.
So
Yeah.
we'll talk about that here in a moment. But anyway, so we're looking at what, three today? I think a rhombus, a rectangle, and a
Yeah.
square
So
possibly.
we're defining some specific shapes today.
So if you look at this rhombus, even before I put this up, you guys should all have made a connection here that a rhombus has four congruent sides just based on the hash marks. Okay, and so that's basically the definition of a rhombus. There's a few more that we'll get into, but at the heart of it, a rhombus has four congruent sides.
No,
Okay?
Mr. Vidal, I thought a square had four congruent sides. What's a rhombus?
Well, the rhombus is basically the daddy of the square. It's just the square has a specific other piece that makes it a square as well as aside from four congruent sides, whereas the rhombus just basically it's the generic four same-sided shape.
Okay.
Square gets a little bit more specific on what makes it a square.
Right, we're talking about the minimum definition here.
Yeah.
The minimum quadrilateral with four congruent sides is a rhombus. That's what it's called. Okay.
Then we have the rectangle, and if you look at the rectangle, some of you guys should also have made some, just deductions based on what you have here. Now be careful here because a lot of you guys may be thinking one thing, but it's not going to be that. But what makes a rectangle is four congruent angles.
Right.
It's got four right angles in it. So that's the basic minimum definition of a rectangle is four right angles. And so once again, this is part square. Okay, where a square also has four right angles, and that's kind of the main definition of the square, guys, is you put those two ideas from the rhombus and the rectangle together, and you get your square.
Right.
And so a square, the definition at the bare minimum is a four-sided shape with four right angles and four congruent sides. There's your square. Okay?
Yep. Yeah, a square is a very specific shape. Four congruent sides, four congruent angles makes a square.
And there you go. There's the two of them. Notice they have it in blue and yellow, just so you know that it's a combination of both. Which kind of brings us to this little diagram here, and this is kind of the family tree, if you will, of the parallelogram family. You got the parallelograms out there on the outside in the big rectangle, and they the arrows move in, and all right, so they're going to go out. So a square, as it moves out, is always a rectangle, it's always a rhombus, and it's always a parallelogram. It shares every single rule of all of those shapes, meaning it's got four right angles, four congruent sides, the opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. If one side's parallel and congruent, then the other side is going to be parallel. I mean, anything that goes into a parallelogram, rectangle, and a rhombus, a square has all of those properties. So the green arrows mean that if you go from a square out, it has all of those rules in it. You want to add anything to that?
Yes, yeah.
And then if we got the sometimes part, so now if we start at the parallelograms and we go in, a parallelogram will sometimes be a rhombus if it's got four congruent sides. Or a parallelogram will sometimes be a rectangle if it's got four right angles in it. And a parallelogram will sometimes be a square if all four sides are congruent and all four angles are congruent.
Yep.
So I mean, it's just, from the most basic in is a sometimes, but from the most defined out is an always. I mean, I guess you can look at it. And then we have, I thought I was going to go to never, but I'm sorry. Anything else you wanted to add there?
To a never?
Yeah, I thought there was a never on. Maybe it's a different one. So.
Okay. Yeah, we have another diagram that's very similar to this
Yeah,
one.
and that's the one I think that has the never in there.
Yeah, so, okay, just to help you organize.
Yep.
Okay. So let's look at some specific examples here. For rhombus, almost think THNK, decide if it is always, sometimes, or never true. So for a rhombus, now again you have to remember what the definition of a rhombus is. A rhombus is just a quadrilateral with four congruent sides. Okay? Actually a parallelogram, sorry, a parallelogram with four congruent sides. So is it a rectangle? Well, the definition of a rectangle was that it had four congruent angles. So no. But a rhombus could potentially be a square, right? And so a square is also a rectangle. So if we just kind of squished this rectangle sideways a little bit and squared it up, then it could possibly be a rectangle. And so the two extremes, always and never, are not going to necessarily happen here, but it could potentially be a rectangle. Okay? And so sometimes a rhombus is a rectangle. And the diagram Mr. Bedell was just thinking about it, talking about if you do the sometimes, that would end up working that way. Okay? Angle T being congruent to angle N, and so again that would basically be opposite angles. Again, sometimes that would be true if this ended up being a square with its rhombus, and so sometimes those angles would be congruent. I'm sorry, they would always be congruent
because it's a parallelogram. Yeah.
Sorry. I got to think back again, the definition of a rhombus. Rhombus is a parallelogram, and opposite angles in a parallelogram are always true, are always congruent, I mean. Okay? Angle T and angle H, again, it's a parallelogram, and so T and H are actually adjacent angles, and from our rules from 2 sections ago, adjacent angles are always supplementary, but this is saying that they're congruent. Okay? Now, when can supplementary angles be congruent? Only if they're both 90s. And is there a possibility these could both be 90s? Yes, if it's a square. And so if this rhombus happens to be squared up again, then that could possibly happen to where they would be congruent to each other. So that's going to be another sometimes, okay, only if it's the particular case of a square. Okay. And the last question here, TH, the top of the rhombus, and HN, the right side of the rhombus, the fact that those are congruent to each other. Well, if it's a rhombus, those are always going to be congruent to each other. All 4 sides are always congruent to each other. Okay? And so that's an always. Now, typically the sometimes are the ones that are the hardest to figure out in those kinds of questions.
Yeah, because it's kind of gray.
Yeah. It's a special case.
And don't just look at this diagram here in this example, guys, to make your decisions, because if you look at it for number 1, I could see how some of you guys could say, oh, that's never, because of the way that diagram looks there, but don't go off that diagram in itself. You got to think, how could a rhombus sometimes be a rectangle, and that is if it's got 4 right angles in it.
Yeah, any rhombus.
Yeah, or it's a square.
Is it possible for any rhombus to be a rectangle, not just the one drawn there?
That's right.
All right. Okay, how about this one? Classify the following quadrilateral. So in other words, what specific, as specific as you can get, is really what it's intending. So as specific as you can get, what kind of shape is that right there? So it is a quadrilateral. Is it at least a parallelogram? Well, if we look at the fact that we have opposite angles being congruent to each other, we have 2 sides right next to each other. We know that the angles inside of a 4-sided shape have to add up to 360. We talked about that. So we got 140 and 140, that's 280. We got other 40, that's 320. So that other angle has to be 40 also. So both pairs of opposite angles are congruent. And so this is at least a parallelogram. Could it be any more specific than that? Well, it's not a square. It's not a rectangle. Could it be a rhombus? Could all 4 of those sides be congruent to each other? And in that one, how would we know that those 4 sides could potentially be congruent? That could be possible, right? They don't give it to us. So based on the given information,
I'd say it's a rhombus, though.
Yeah?
Because on a parallelogram, opposite sides are congruent. So if that one there on the bottom is 1 hash mark and that one on the left is 1 hash mark, if you use the opposite sides are congruent idea,
parallelogram.
Yeah, then you would know that all 4 of those sides should get 1 hash mark.
So if we know it's a parallelogram for sure, then we know that opposite sides are congruent. So the left and right side would be congruent.
Yep.
We know the other opposite sides are congruent, the bottom and the top. And so really we do know that all 4 sides of that are congruent. And so we can narrow that very specific shape down to a rhombus. It is a rhombus. All right? Okay. So we just got to go through all the rules to try to narrow that as much as possible.
And that's really going to be the challenge is can you visualize this enough to remember? It's not hard math. It's just can you think back to all the things we've been doing all year long to make some visual connections?
Right.
So,
and some specific things here with parallel sides and so on.
Yep.
Right?
All right, so if a parallelogram is a rhombus, if its diagonals are perpendicular. Okay, so this is a definition. I thought I was asking a question.
Yeah, there's a new rule now, new theorem here.
So there's another rule. So a parallelogram is a rhombus if its diagonals are perpendicular. So now pay attention to what it's saying. It's not saying that the diagonals are congruent. It's saying that they have to form a perpendicular in the middle. Now it's already a parallelogram, so you know that those diagonals bisect each other, but in order to be a rhombus, when they cross, they got to form a 90-degree angle in the middle.
Now, Mr. Bedell, I'm noticing something in this definition that I changed on this slide, and so I'm not sure if, with your students, if you talk about this, but I've told my students that an if with two F's is an if and only if, and I think on previous slides, they put it IF, IFTF or something?
Yeah.
If and only if, or IFOF or something. It was some other acronym for it. And in mathematics, an if with two F's on it is if and only if. So this is one of those that goes both ways. So this is one of those that a parallelogram is a rhombus if its diagonals are perpendicular, but it goes the other way too. If a parallelogram has diagonals that are perpendicular, that forces it to be a rhombus. So this is one of those that goes both ways. This is an if and only if statement. And so we will have some where we will prove the diagonals perpendicular. That forces it to be a rhombus then.
Okay.
But if you know it's a rhombus, then you know that four right triangles get formed inside there too.
Oh, that's true.
So, all right.
Very cool. All right, and so here's another one. I'll read it better this time. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So if you look at the diagram, it kind of explains it all. Now notice I'm not focusing in on the perpendicular, so you don't necessarily know that here, but you do now know that it's a rhombus because those opposite angles are bisecting each other. So I mean that makes it a rhombus. So it's one of those. These two here are kind of those ones that are just kind of out there.
Very specific to rhombuses.
You know,
yeah.
and you don't see them that often, but they do sneak up on you. I mean, so, you know, a lot of time we just focus on the sides of the rhombus sides, but now you got to look at the insides and those diagonals, and that's something we haven't really talked a lot about this year, are diagonals.
Mm-hmm. Yeah.
You know, so.
Yeah, and so this ends up setting up all kinds of congruent triangles inside here
Yeah.
and so on. It can get a little confusing, so you got to make sure that you can see all those different pieces there.
Yep.
So, okay.
And then a rhombus is a rectangle if and only if its diagonals are congruent. So here finally we get
Oh, this is an important one.
to where, yes, to where the diagonals are bisecting each other, and now they're also congruent to each other, all four. So if you look at the diagram, you see that there, that all four diagonals, or all the four pieces of those diagonals are now all the same. So not only do they bisect each other, but they are congruent. So you know, just remember that for a rectangle. That's another rule that makes a rectangle, not a rhombus, but a rectangle. Okay?
Yeah, and this is used a lot in construction, a lot in just putting together like cement forms or whatever.
Right.
If you take a measurement diagonally across, you know, if we were pouring concrete inside that shape and we wanted to make sure it was at right angles, then we would measure those diagonals before we nailed that in place to make sure that the diagonals are congruent. If the diagonals are congruent, it has to be a rectangle.
Yep.
What does it mean to be a rectangle? It means that there's right angles inside there. All those are right angles. And so that's used a lot.
So you become square, right?
Right. Yeah.
All right, so now use square PQRS to find X and Y. So if we know that this is a square, then the rules of a rhombus come into this, or the rules of the square say that all four sides are congruent, and that the four right angles, and then also since a square is part rhombus, okay, that also means that 5x and 3x plus 18 are congruent to each other because the diagonals of a rhombus bisect the opposite angles. So when we go to set this up, we could just go 5x equals 3x plus 18, and then you know, minus the 3x to the other side, and you get 2x equals 18 and x equals 9.
And some of you might see it a little bit differently. We can use that rule, but it also applies that those are alternate interior angles.
Oh yeah, that's right. Yeah, you can go back to the parallel rule
bottom
for
being
sure.
parallel. So,
For sure.
yep.
Yeah, I mean, there's the biggest thing here, guys, is this is just a good example of how Mr. Scritchfield and I are both math teachers, but we look at things and we remember all the different rules there are, and then so he looks at it and sees parallel lines. I look at it and see, okay, there's some rules of the rhombus. Did we get to the same place? Yes, and is that the important thing?
Yeah, and as we progress through the year, we're getting
Yeah.
more and more tools to use, and so it would be good if you saw it multiple ways.
That's right. That's
So-
right. It's part of thinking.
Yep.
And then for the y's, okay, now since a square is also part rectangle, we know that those diagonals bisect each other and they're congruent, and so, well, that's just a parallelogram rule, but we know that 2y is congruent to 10, so we just say 2y equals 10 because the diagonals bisect each other, and so y is 5.
Yep.
So.
Yep.
All right, now we have rectangle QRST has a diagonal QS equals 10. Okay, so I don't know if this puts it in there or not. What do they want us to find? Here we go. So we got to find the measurement of QPR. All right, so that angle right there in the middle. And so we got to figure out what RP is. Well, we know that QS is 10. So we also know that RT is also 10 because in a rectangle the diagonals are congruent. So we know that if RT is 10, then or if QS is 10, then RT is also 10, and they bisect each other. So that means that PR is 5, or RP is 5. So I'm going to put that in there right now. Okay, find the measurement of QPR. My bad. Okay, so in the second question, guys, we have rectangle QRST has a diagonal of QS, which equals 10. Okay, and so then they want us to find the measurement of QPR, find RP, and who is QR congruent to. So that's easy. I mean, or we'll get to that here in a minute. But a couple things that you need to be able to pull out of this when you do that is the fact that QS is the same as RT because they're diagonals in a rectangle.
Right.
We'll talk about that more here in a moment. Let's focus in on finding the measurement of QPR. So if you find QPR, it's that angle up there on the top. And you just got to think back to some of the rules we learned about rectangles and parallelograms. Well, we know that the rectangles' diagonals are congruent, and we also know that a parallelogram's diagonals bisect each other. So that makes triangle SPT, that one on the bottom where the 34 degree is, an isosceles triangle. Yep. And so if that angle is 34 degrees down there at the bottom left corner, then that angle PST on the bottom right corner is also 34 degrees. And so if I just take 34 and add 34 to that, I get 68. And if I subtract 68 from 180, that tells me that angle TPS is 112. And then based on the rules of vertical angles, if TPS is 112, then QPR must also be 112. Right. And guys, this is this thing that Mr. Scritchfield and I keep coming back to.
There's a bunch of ways you could do that.
Yeah, you have to reason through these things. If you can't reason through this and you can't pull out information, it has nothing to do with how well you add and subtract. You will not get there. Mm-hmm. You have to be able to look at this and come up with some ideas.
Yeah.
You know. And now for RP, if QS is 10, then RT is also 10, and then half of 10 is 5. So that puts me there at 5. And if who is congruent to side QR? Well, that's pretty easy. It's side TS because opposite sides of a parallelogram are congruent, and a rectangle is a parallelogram. And so
they want us to actually find the length of that, I guess.
Oh, so they want to find the length. Okay. So if they wanted us to find the length of that,
we're going to go back to last chapter.
Yeah. So now you got to go back to your trig rules. Okay. And so since we know that RT is 10, we have a hypotenuse now, and so we have a hypotenuse. And we want the adjacent, and QR is the same as TS, so I can use TS in place of QR and still get what QR is worth. So now all I got to do is go, since I want that adjacent, I go cosine 34 equals x, which is the adjacent, over 10, which is the hypotenuse of that right triangle on the bottom. And I just multiply those together diagonally, and I get 10 cosine 34 equals x, or 8.3. Okay.
Approximation of that length, yeah.
Yep.
Yep. So we're kind of mixing some things here. So
yeah.
It keeps building, guys. You got to stay with us. All right. So that's 8-4.
8-4.
Pulls us together.
Okay.
See you guys in class.